What's up guys, I'm Rasim from RasimTech.com and this is another tutorial in assembly programming. Now in this class I'm going to talk about the push and the pop instructions, so let's get started. Let me first start off by saying normally when we move a value from one area into memory, we have to specify the exact address. The program would have to specify the exact address in memory, right? Which takes up time, it slows down the CPU, and it's just really inefficient altogether. But assembly programming, they figured out a way around this. Now they figured out a neat technique which they call push and pop, so you don't have to write those addresses. So let me show you exactly what push and pop do. Now over here I have a stack, right? This is a memory stack. Let's first talk about push. Push, when we use the push instruction, it stores the data on the top of the stack. It goes all the way on the top and it looks for the first unused memory address on the top of the stack, right? So it'll go all the way on top and look for the first empty spot, which would be this. Let's say I use the push instruction right now down here. Let's say I push AX, right? And let's say AX had the value of, let's say 1 2 3 4 space 1 2 3 4. I'm sorry, 1 2 3 1 had the value of 1, right? Once I hit push AX, it's going to take this value, right? And it's automatically going to copy it to the first empty spot on the top of the stack. This would be the first empty spot on the top of the stack, so it would paste it here, right? So every time we push, it copies data on the top and it looks for the first empty spot. So the reason why this is more efficient, again, let's say when we're moving memory in a program, normally we have to specify exactly what that address and the size and everything, and that takes up time. That's more lines of programming you have to write, and it slows the program down. So that's why we use the push instruction. But now let's talk about the pop instruction. Now the pop instruction retrieves data from the top of the stack. So let's say I used pop AX, right? Now push AX, whatever value is in AX again is gonna be saved in the first unused spot on the top of the stack. Let's say I pop CX. Now pop goes all the way on the top and it's gonna look for the first pushed or the last pushed spot. So this would be the last push spot. It takes this and it copies it, right? And it'll copy it straight into CX. So that's what pop does. Pop retrieves the data from the top of the stack, basically. So there's no need to specify exact addresses, and it's just really simple to do. If you want to it can be used as a placeholder, and it's really simple to do. So let me demonstrate this in a program. Let's open up MU8086 here. Now, first thing I'm going to do is I want to use the AX register, and I want to give a value to the AX register. So I'm going to move into AX, the value of 1, right? So the AX register has a value of 1. Now I'm going to now I'm going to push AX. Okay, again, AX has a value of 1, right? Once we use the push instruction, AX, it's automatically going to be copied to somewhere on top of a memory stack that's empty. So let's say this would be the next, we just use this one, right? So let's say this would be the next empty spot. It would copy that and paste it onto here. That's all it is. So let's go back to MU8086. So now let's say we pop now. We want to pop CX. And again, pop retrieves data from the top of the stack. So once we pop, it's gonna jump to the next spot that was used, the last push point basically. It copies that and it stores it into the destination, right, which would be here, right? And now let's hit emulate. Let's hit the first step. We're gonna move into AX value 1, right? So the next step, we're going to push AX. Again, once we push AX, again, it's gonna copy it to the top of the stack at the first unused spot. Now let's go back to the program. Now we can hit next step. Next step is going to pop CX, right? Once we hit next, it's going to pop CX. So as you can see over here, CX now has a value of 1 because it pushed AX, right? AX had a value of 1. It pushed it on the top of the stack Then once it got to this point here, once it popped CX, it went to the top of the stack and it copied the last spot that was pushed, and it copied it into CX. So that's why CX here now has a value of 1. So that's pretty much it. It's really simple. If you guys enjoyed this video, please give me a like. If you want more videos like this, please subscribe to my channel. I'm Rasim from RasimTech.com, and thanks for watching.